Hello everyone, this is Oraño and I will be solving problems about first-order differential equations from the Advanced Engineering Mathematics 5th edition by Wylie and Barrett. So my first problem is found on page 25, number 13. If phi xy is an integrating factor of the differential equation mxy dx plus nxy dy equals 0, show that phi satisfies a partial differentiation equation m times the partial phi with respect to y minus n times the partial of phi with respect to x plus the quantity partial of m with respect to y minus partial of n with respect to x times phi equals 0. So first we will manipulate this equation. Mxy dx plus nxy dy equals 0. We will divide both sides by dx to get mxy plus nxy dy over dx equals 0. This equation somewhat looks familiar. It looks more exactly like exact differential equation, but let me remind you that just because an equation is written like this, it doesn't guarantee that this is an exact differential equation. So what we're going to do is we're going to assume that this equation is an exact differential equation where mxy and nxy are known functions of x and y. And there is a differentiable function phi, which is equal to phi xy, such that mxy is equal to partial of phi with respect to x, and nxy is just equal to partial of phi with respect to y. From these, this differential equation can also be written as partial of phi with respect to x plus partial of phi with respect to y dy over dx equals 0. By chain rule, the left side of this equation is just equal to multiply both sides by dx, and we can integrate this to get phi xy, which is equal to c, where c so we already have our integrating factor phi xy, which is just equal to c. So now we're gonna proceed and show that phi satisfies a partial differentiation equation. Partial phi with respect to y minus n partial phi with respect to x plus partial m with respect to y minus partial n with respect to x times phi equals 0. So m partial phi with respect to y is just equal to 0 since phi is equal to constant, minus n partial phi with respect to x is also equal to 0. And take note that since we're assuming that the differential equation mxy dx plus nxy dy equals 0 is an exact differential equation, the partial of m with respect to y is just equal to the partial of n with respect to x. With that said, this is just 0, so plus 0 times phi equals 0, so n times 0 is just equal to 0, n times 0, 0 plus 0 times phi is just equal to 0 equals 0, so we get 0 equals 0, which shows that phi, which is equal to c, satisfies this partial differentiation equation.